Okay, today we're doing some solving of systems of equations by using our calculator. We're going to be using a Ti-Nspire CX. So yours may or may not be the same, but that's what we are using for class. Okay, so first of all, what we want to do is make sure that our system of equations is in standard form. Okay, for standard form, that means both of your x's and your y's are on the same side of the equal sign. Okay, so both equations, right? We're going to have two equations, two variables. They both need to be on the equal side so that we're setting our matrix up correctly. Okay? Because what we're going to do is we're going to take this and we're going to write it as a matrix and let our calculator do all the work for us. Okay? So this is what I want to see on my students' paper is the matrix that they're plugging into the calculator. Okay? So now each of these variables is going to have a coefficient. Okay? So everyone's going to have a if there doesn't have a coefficient and there's a letter there, then your variable is 1. I mean your coefficient is 1. Okay? So as long as there's a letter, then you have a 1 for your coefficient. Okay? So we're going to create a matrix by writing down our coefficients. Okay, so notice we have the x column. This is the coefficients of your x variables, and these are the coefficients of your y variables. So we have a column for x and a column for y, and then we have a column for our answers also. Okay, so you put your answers as the final column over here, right? And those are both numbers, somewhere between a large number and a large number. Okay, so that's what we're trying to do is we're trying to make our matrix look like this. Okay, and then we're going to put it into our calculator and let it solve it for us. Okay, so those are coefficients and numbers. So let's look at our first example. Is it in the correct form? Right, the answer is no. Our y is on the wrong side of the equal sign, so we have to move it to the left side of the equal sign. And we do that by, of course, subtracting. So we're going to rewrite our bottom equation as x minus y equals positive 4. Okay, so that's first, is we have to get both of our equations into the right form. Okay, sounds easy enough. We can do that. So now let's create our matrix. So we're looking at our coefficients only. So if we look at the coefficients of our top equation, that has an x coefficient of 3 and a y coefficient of -1 and a number answer of 8. Okay, so that becomes your top equation. We have your x coefficient, your y coefficient, and your number. And we do the same thing with our second equation. We have an x coefficient of 1. There's one x there. We have a y coefficient of -1, and we have a value of 4. Excellent. So now we're going to put this into our calculator using what's called reduced row echelon form. So on our Ti-Nspire, this is what we're going to look for. When we hit the menu button, we come up with this, and we're going to do our matrix and vector. So you're going to click on that one, go down to 7, right? And then we're looking for number 5, the reduced row echelon form. Okay, that's what we're going to use. So we go down to 5, and we click enter, and our calculator brings up the RREF with some parentheses. Okay, so now we're going to have to hit some other buttons. Let me show you which button you hit now. This is the button we're going to hit now, right here. This gives us all of our options that we're trying to find. And when I hit that button, I get all of these options. So these are all the things that I could insert into my parentheses. Well, you see the one that's highlighted is this one. That looks like it's a 3x3 matrix. But when you click on that button, we get this menu, so we can make whatever size of a matrix that we need. Well, looking back at our problem, we had 2 rows and 3 columns. So we need to come in here and change this to a 2-row and a 3-column. So this is what we get when you press enter. We have a 2x3 matrix, and we're going to put our 6 numbers into each of these spots. Okay, put our 6 numbers into each of those spots. And those numbers come from your matrix that you just created. So I'm going to put each of these 6 numbers, 3, -1, and 8, and then 1, -1, and 4, and fill up my matrix. Right? So I'm going to have six terms within my matrix, and when I press enter, it's going to give me the answer. And this is what my calculator says. So now let's interpret our answer. Okay, so remember what our first column variable was. The first column was the x variable, which means my first value in that row is going to be my x answer. So my x value of my solution is +2. And then the second row, that was my y column there. And if I go across where the 1 is, that means your second value is the answer for your y term. Okay, so it's not going to tell you that, of course. You have to interpret, remembering that your first column was the x and the second column was your y. So here we have a 1 representing 1x, and here's equals 2. And here we have a 1 representing 1y equals -2. Okay, so we can use RREF to do all of our solutions for all of our matrices. Okay, so that means the solution to this system is going to be 2, -2, because the solution is always a point at which the equations or the lines intersect. Okay, so let's see if we can do that some more. I'm not going to take pictures, but we'll look at the RREF and what are we putting into our calculator. So if this is your equation, if this is your system of equations, the first thing we do is we make a matrix out of each equation with just the coefficients. Remember, we're just using the numbers, no x's or y's involved. So this is a 2, 1, and a 6, because there is one y, right? We're never going to write a 1 in front of a variable. You just have to understand that there's 1 there. And our second equation gives us our second row, -3, 2, and 5. So this is the matrix that I'm going to use RREF on in my calculator and then interpret the answer. So that is what my calculator gives me as the answer. So interpreting my answer, that means my x answer is 1, so x equals 1. And my y answer is 4. X equals 1 and y equals 4. Okay, so you still have to go and interpret your solution because your matrix does not interpret things for you. That's for your amazing brain to do. Okay, so let's look at another example. This one is going to be strange, which is why I threw it in there. Okay, we're going to have some very weird answers. So we have 2, -4, and 6. And we have -1, 2, and -3. So this is our 2x3 matrix. Okay, and we're going to put it into RREF and see what our calculator gives us. So notice our strangeness. We have all numbers on the first row, but then we have zeros on our second row. Okay, that means there isn't an x value, and there isn't a y value, and there isn't a... Right? This means that we have an infinite amount of solutions. Infinite solutions. Okay? And how that happens, of course, is that one of our lines, our 2x minus 4 equals 6 line, is actually the same exact line as -x plus 2y minus 3. Right? These are the same exact line. They have the same slope when you solve it for y, and it has the same y-intercept. So if you have one line that is exactly on top of the same line, then we have an infinite amount of intersecting points. Right? Every xy is a solution if they're the same exact line. Now, if there's a no solution, okay, then your matrix will not have any x or y's, but it might have a number in that position. Okay, so this is how you know it's going to be a no solution, is if you have zeros for your x and your y column, and then you have a number in your third column there. Okay, so it's important to understand the weird ones, right? When something is abnormal, that means our answers are abnormal. So you either have an infinite solution if we have all zeros in one row, or we have no solutions if there's zeros for your variables, but then a number in that column right there. Okay, you might see that once in a while. So let's look at our next example. We have an actual word problem, which is where we use these most often, because nobody likes solving word problems. I know you don't, so don't worry. But we're going to make a matrix and let the calculator solve it for us. Okay? So we have 3 burgers and 2 orders of fries. So we have to assign variables. Let's let burgers be x and fries be y. Okay? So that equation would look like 3x plus 2y equals $14. Right, so that's our equation for your order of 3 burgers and 2 fries. Okay, your cousin, it says, ordered 2 burgers and 5 fries for $15.75. So we can write that equation as 2x plus 5y equals 15.75. Okay, so these type of problems are really good for a matrix to solve. Your calculator loves doing this kind of stuff. So this is the matrix that we're going to plug into our calculator. And let's see what it gives us. So if we interpret this, our x is your burger. Our burger costs $3.50 for every burger. Burger, B-U-R, silly me, B-U-R. $3.50 for a burger, and 1 fry is $1.75. Okay, so we go back and we interpret. We called x your burgers and we called y your fries. So not just x and y, but burgers and fries. So $3.50 for every burger and $1.75 for your fries. Okay, so sometimes we're going to write equations that have 2 different ideas, right? Since we had burgers and fries and dollars. Well, these next ones have 2 separate, distinct ideas. Okay, Noah has a jar of nickels and dimes, and there are 200 coins with a value of $14. Okay, so there's 2 types of situations that's going on here. One is the quantity. How many of each coin do we have? So we're going to write a quantity equation. And the next one is about value. What are each of these parts of money worth? Right? We have $14 of value in our coins. So we have nickels and dimes. Let's call nickels X, and we'll make dimes Y. So if I were to add my nickels and my dimes, how many would I have? 200, right? So I have X plus Y equals 200. Some amount of dimes plus some amount of nickels equals 200 total coins. And now, what about my value? What is every nickel worth? 5 cents. So there's a couple ways we can write it. We can write it as 5 cents. Okay, plus, how much is a dime worth? 10 cents. So 10 for every dime equals, well, if this was in cents and this is in cents, that means my $14 has to also be in cents. I can't say equals 14 because according to my units, that means 14 cents because these are in cents, this is in cents. So this would have to be cents. So if we're going to use cents, how many cents is $14? 1,400 cents. 1,400 cents. Okay, so we also could have written it as dollar amounts. A nickel is 5 cents out of a dollar, so 0.05. And then our dime is 10.10 of a dollar equals $14. So if this is how you interpret it and you write all dollars, right, these are dollar values, then you can use this also. Okay, so we're going to put it as a matrix and let our calculator do all the work. But in each of your word problems, they have a quantity, how much are we having, and we have a value. What is each of these things worth? Okay, so RREF is a very fantastic way that we can use to solve a system of equations. Have a great day.